All right. Hey, everyone. Thanks for joining us. In whatever time zone you're in, good morning, good evening, good afternoon. This is WireMock Live, and today we're going to be talking about chaos engineering. So my name is Ethan Jones. I work on product here at WireMock. This is going to be led by Dan Perovich, who leads customer success here. We do WireMock Live every few weeks. We cover a different topic specific to the WireMock product, some capability, going deep on it, or something new that we want to talk about. So today is about chaos. The next one is going to be about going beyond the basics. That's a good one. We encourage you to join that. Um, if you want to ask questions, we would love that. Go ahead and put them in the Zoom Q&A. We want to make this very dynamic. We are going to get the recording out to everyone after, so you can share this with all of your teammates who aren't able to attend. We're also going to put our emails in the chat. So if you want to follow up on chaos or any other WireMock topic after the call, please do. We'd love to work closely with our customers and with our users as design partners. So anything you want to give feedback on, anything you want help with, anything you want to talk about, please don't hesitate to reach out. So again, we will drop those emails in the chat in just a minute. Make sure you ask your questions in the Q&A, and we'll go ahead and get started. Take it away, Dan.
Great. Thanks, Ethan. Hello, everybody from the Washington, D.C. area where I'm currently sitting. Just one point to add to what Ethan mentioned. Of course, feel free to ask any questions at all about WireMock. We kind of like to leave some time at the end for an Ask Me Anything style session. We'll definitely address any questions about chaos first, and then with any remaining time, we can answer some other questions there if there are any. So let me go ahead and get my screen shared here, and we'll get started. Here we go. Get my Zoom stuff out of the way. All right, so what we're looking at here for today's demonstration of the chaos engineering module of WireMock Cloud is a pretty simplistic mock API that consists of 4 stubs. Now, traditionally, earlier stage testing, we would use edge case scenarios, rainy day scenarios as individual stubs. So in the case of what I have here, so we have one sunny day scenario where the get thing one responds back with no delay. And as a refresher, right, every stub can have a delay set of a no delay, a fixed delay, a random uniform delay where we pick an upper bound and lower bound, a random log normal delay, again, upper bound and lower bound, or a chunked dribble delay, which is often helpful for those mobile testing use cases where our responses could be split up because of hopping between cell phone towers and such. So in our setup here, we have get thing one with no delay. It's just going to respond back as quick as possible. Our get thing two has a 3-second fixed delay configured for it. Our get thing three is exercising one of our network fault responses. So a rainy day scenario here where we're emulating a fault on the network between our consuming application and our producer or mock API here. And then our get thing four is a standard style of response, but again, a rainy day scenario where we're sending back a status code of 400 and a custom message of route not found. Now, using these, we'll demonstrate, kind of how these will work. Of course, each one of these would match as we would normally expect inside of our test requester here, or from any consumer, whether it be a front-end application, middleware, or some type of testing tool. So we can see those are all behaving. Now, what do we want to do, though, as we reach later stages in the SDLC and get into performance testing and reliability testing, or maybe even towards the left in our SDLC, where we really want to start to exercise our error handling, retry logic, and configurations? We'll want to shift over to using more of a chaos style of approach. So let's hop into there and take a look at what we have in our settings. So first, you'll see that there is another setting for API delay in our chaos module here of WireMock Cloud. The way this particular piece works, you'll notice that it has a fixed delay, a random uniform, and random log normal as well. When we go ahead and set a delay inside of here and click save, this will in effect apply a delay to any stubs that have no delay set to them already. So if you remember, I'll refresh your memory here, that thing 1 had no delay and thing 2 already had a 3-second delay on it. When we configure this API delay, this will only affect those ones that have no delay set on the stubs. So if we take a look at thing 1, remember this is the one with no delay, we can see that this should come back no longer immediately, but it's taking roughly 3 seconds to respond, 3,000 milliseconds as we've configured our API delay. Whereas if I hit thing 2, which already has a delay configured in its matching stub, we should see that that response is what we had configured over there. Now, I understand this is a little bit silly, so maybe we change this to 2 seconds and 3 seconds so I can demonstrate this a little bit better for you. So if we're on thing 2, we should expect it to see its already pre-configured stub delay time. But if we go back to thing 1, we should see that this API delay, more of a global setting, is being applied. And there's our 2 seconds as opposed to the 3 seconds. So that's the first piece I wanted to cover with API delays. The piece that I really like to talk about and gets customers really excited, though, is in our chaos, true chaos section down below. And you notice there's a few things going on here. One is a toggle to enable and disable our chaos settings here. And the next is this percentage of failures. So we can set a percentage of failures that we're interested in achieving with this slider bar here. Our next step is actually to enable some types of failures that we're interested in having our mock API exhibit. So whether that's the socket closed, socket reset, the invalid HTTP response, maybe it's a long response time delay of 5 seconds or whatever you want to configure that here for. And then various different response codes that we're interested in sending back at random. So I'm going to pick 2 here, and we'll save my settings in a second. But I want you to notice that these percentages are dynamically updating here. So as I move the slider, we can see roughly, statistically speaking, how often we would expect one of those failure types to fire if we go ahead and enabled chaos on this. So let's go ahead and try this out. We'll enable chaos, and I'll click save on this. And now we'll try our sunny day scenario that had, remember, it had no delay configured, and our global setting inside of chaos is no delay. Let's see what happens when I hit thing 1 with chaos mode enabled now. First time I hit it here, we can see that the request failed due to a network error. Hit it again, network error, hit it a 3rd time, we get our 404 not found. We hit it again, we see we have our 501 coming back now. And as we continue to hit this, we'll experience those various different types of errors that we have selected over here, happening at complete random, right? WireMock choosing one of these for this percentage of failures. Now I'll point out that when you enable chaos and these failure types, these settings, if it comes up, the lottery ticket is drawn that this should be a failure based on your percentage of failure, the failure type configured down below will completely override what your original stub has configured. And we just saw that happen, right? We were hitting the get thing 1, which was a complete sunny day scenario with no long response times occurring. And we saw it being failed and not getting the result that we expected instead. And if I come down here and maybe delete some of these, and we can see this firsthand, long delay, maybe we set this about 50%. Let's go 25% of the time as a last example here. We'll hit save, make sure our chaos is enabled, and we're going to hit thing 1 again. Again, this is a sunny day scenario with no response time configured. We see it came back immediately. This time, we're waiting a little bit longer. So we can see that these response times, right, are being affected. Here's that long response time. So 5 seconds happening here for that response time to come back. So we can see that randomization trying to achieve statistically a 25% chaos failure rate here with this configuration set that we had. And again, completely overriding the way that thing one was configured to behave. So we'll show that one more time with invalid HTTP. We'll see that sometimes it's going to respond back immediately, body content for thing one. We send it a few more times, trying to get that 25% statistic to hit here. And we should see an invalid HTTP error come back when we actually hit that piece. So here we go. Here's that request failed due to network error based on the chaos. Using this, right, in our performance testing and our reliability testing, we can adequately test all of that retry logic, the wait times that we have configured for long delays, the attempts that maximum number of attempts that we might have on a various endpoint before we send an error message back to the consumer, and so forth. I'll point out that we do have inside of wiremock.io/academy a video up with chaos engineering. It's 3 minutes and 17 seconds. Also related to this is another approach that if you really do want to try, retry counts and get a little bit more fine-grained, there is another video here called Client Code Resilience, about 4 minutes and 38 seconds, that will teach you how you can perform a similar concept using WireMock scenarios, but that's a topic for a different time. With that, let's take a look and see if there's any questions here. I see, and Ethan, maybe I'll have you MC the questions.
Yeah, absolutely. We do have one that I think is a good clarification. So Priya asked, if the chaos is enabled, do we ever get the successful response, or is it always going to be an error? And I think you were showing that goes to how you configure it, right?
Yeah, that goes to how you configure it. So of course, if I put chaos all the way up to 100%, then we're always going to get one of the failure types that we have enabled. And remember that they are going to be statistically distributed equally across all the failure types. So at 100%, we would expect any request coming into our mock API to receive one of these failures. If I take this down to 50%, then we'd assume that 50% of the time we'll get our response as we configured and intended from the stub configuration. And the other 50% of the time, we would expect one of these failure types.
Awesome. And Manish just asked, can you get the chaos functionality in the standalone jar, which I think is referring to the open source package?
No, you cannot. This is a WireMock cloud-only feature.
Yep. Okay, we got another good question here. So you showed earlier on the kind of chaos light stuff that's in the stub configuration, the delays. What are kind of the scenarios, or maybe not scenarios since that means something in WireMock, but what are the use cases in which you might want to use the stub configuration version versus kind of the full-blown chaos settings?
Yeah, sure. Great question. So I would say more in the unit testing and why we're actively developing, we would probably lean more on using the stub-based configuration. I often, when I demo, always make object number 8, right? So thing 8 typically be an error scenario. And then we can very fine-grain control our and develop our error handling logic and our response body messaging and how we're going to handle those particular errors in our consuming application code. So I would say as a developer who's actively coding and needs to test against these very finite types of errors, that they would often rely on the stubs and using individual stubs like you see me configured here, thing 4 being a rainy day 404 scenario, thing 3 being a rainy day network style scenario. Whereas again, shifting a little bit further to the right in the SDLC as we start to, ramp up into continuous integration, regression testing, as well as all the way to the right in performance testing, full on reliability testing. That's when we would shift to chaos most likely.
And we got another question here. So for unit testing, I'd want to pre-configure this without further human intervention. Are there things that would support that?
So yeah, we do have APIs for configuring chaos. So we could use the APIs to go ahead and enable, disable, and change the configuration set inside of the chaos screen. WireMock Cloud is developed API first. So everything that you're seeing us do on the UI is accomplished via our APIs. Now, there might be an off chance that it hasn't been there's not a published API for it. But if you're feeling that you can't find a published API or anything that can be done in the UI, feel free to reach out to myself or the team or in the support chat bubble, and we can certainly help you out with that, as we are going through an active effort to refresh our documentation, bring our API documentation into the open API age, right, for all of our customers. And you should see any of those particular gaps closed in the near future here. But again, please don't feel free to reach out if you feel there isn't an API for something that is done in the UI today.
And if there's any kind of elaboration on that question you want, go ahead and drop a follow-up question in the Q&A. We're definitely happy to keep going if we didn't cover it. We got one from Javier here. Could scenarios and chaos be combined? Following the expected step-by-step and at some point trigger the chaos situation and then continue with the flow of the expected scenario?
Wow, that's a great question. So that's probably something, Javier, that I personally don't have an answer for you right now. There should be no reason that scenarios can work with chaos. Where my hesitation is, and I just have to say I don't know yet because I haven't tried, is does the scenario state get affected if chaos tripped on the response of that stub, right? So that's the point that I frankly don't have an answer. So that's something I'd love to chase down, and we can reach out with an answer on that, Javier, and let you know. I have a feeling, based on the way that I've seen all of chaos perform, is that it does short circuit the rest of the execution of the stub. So my thoughts are that the state machine would not be affected. You wouldn't be changing the state for the matched stub, because the failure execution actually happens before the stub is matched. Typically, there's a couple of caveats in there, ones that I will dig into with our engineering team and follow up with you. But great question. Thank you.
Yeah, and I think we can agree it's a great question. So we'll follow up, and either it works that way, or if not, I think we'd love to log that as a possible future enhancement, because I can definitely see the utility of that.
Absolutely.
Awesome. So we got another question here. I've heard of chaos in the context of like live production services. There's tools like Litness out there that do things like that. What would I be thinking about slightly differently if I'm thinking about chaos in these terms, where it's related to the API mock server?
Yeah, so good question. I used to work at New Relic, and we would run into a lot of game day scenarios where they would send the chaos monkey into sections of production, not production. So I mean that's absolutely one way of doing it, and a highly advanced way of testing in production. But I think where we're looking at using WireMock Cloud and these chaos capabilities is really pre-production and focusing on that, especially around third parties. It's there's no 100% successful API, even internal APIs, external APIs out there in production. They all exhibit some types of failure. And we want to make sure that we're testing for that as early as possible. When you typically hear chaos and chaos monkey and game day scenarios, you're typically, in my experience, again looking at mean time to recovery exercises and how fast can we detect this issue in production and remediate that issue in production, where our this type of chaos with stubbing and mocking is really looking at fine tuning our error handling, our retry logic, right, and really trying to find the best code and configuration set for retries and timeout values well before we release into production.
Something I think you said there, Dan, that's worth calling out is you mentioned with like third-party APIs. So there's going to be dependencies where you actually can't properly do chaos if you don't own the service upstream to inject the chaos into it. So when you've got reliable mocks of those third-party APIs, this is an especially good way to figure out what happens when those third-party APIs act up, because most sandbox environments you get from third-party vendors or most test APIs don't give you the ability to simulate failures on their APIs, probably because they want to tell you their APIs aren't going to fail. But you still want to be protected in case they do.
Yeah, great point. Great point.
Okay, awesome. It looks like that is all the questions. We will chase down an answer to the question on the scenarios and maybe include that in a follow-up message. We'll get you the recording for this as well as the link to sign up for the next one if you're interested. Like I said, our emails are in the chat. They're pretty easy, Ethan@wiremock.io and Dan@wiremock.io. If you want to have a follow-up conversation on this or any other WireMock topic, if you have any suggestions for things you'd like to see us explore in the future, please do reach out as well, and have a great rest of your day.
Thank you all.